Okay, continuing with the review for Mac 1105, Chapter 2, Problem 31. Okay, we're given f of x is equal to 5x minus 1 and g of x equal to 3 over x plus 7. You're asked to add these and find the domain. So f plus g would look like this, 5x minus 1 plus the g function. There's no need to try and get a common denominator here and pull them into one fraction because the question is merely what is the new domain for this sum. So all you have to think about is that there are two pieces that went into this sum. This is the portion that needs to be protected. You may not use x equal to negative 7. So x cannot be equal to negative 7. This doesn't need protection because it's just a linear portion of the entire function. So on a graph, x not being allowed to be negative 7 looks like this. You'd have a hole at negative 7. Everything to the right is usable. Everything to the left is usable. And you want to state for your new domain, what are the things that are allowed to be used? Again, that's all of this, all of this. You may not use the negative 7. So you're going to state that interval style. The numbers that are out here are negative infinity. The numbers that are out here are positive infinity. So start on the left. You may use anything from negative infinity up to, but not including, negative 7. Then you're going to make yourself jump over negative 7 by using a union symbol. And you'll start right back up at that number using a parenthesis to mean that you can't use that actual number, and everything off to positive infinity is good. Okay, likewise, number 32 is the same type of problem. They give you f of x is equal to 3x plus 9. G of x is equal to 3 over x plus 4. Again, they've asked you to add these two and find the domain for the sum that you're creating. So one portion of the sum is linear and needs no protection. There's nothing that could make this undefined, whereas the other portion of this sum is a fraction and you have to protect the denominator. Okay, so as not to allow this to be undefined, x cannot be negative 4. On a number line, saying that x cannot be negative 4 would look like this. You'd have a hole there, meaning that you could use anything to the right of negative 4, anything to the left of negative 4, anything to the right. So this is everything from negative infinity up to, but not including, negative 4. Jump over the non-allowable value. Pick up right there all the way to positive infinity. But when you wrap this parenthesis around the negative 4, you're starting at that endpoint but saying that it's non-usable. Okay, these are all the things that are allowed for the domain, but you can't state what the domain is unless you mention what it can't be, which is why you draw this picture out and try to observe the values that are non-allowable so that you can state in the end what the true domain is. Okay, picking up with number 33, you're given two functions. F of x is equal to 4x squared plus 2x plus 6. You're given a g of x function, which is just a nice linear function, real simple. And then you're asked to construct g composed of f. What this really means is that you are plugging one function into another. That's what a composition is when you have an open bubble like this. You're going to open up the front function always, and you're going to substitute the back function into the front function. So opening up the g function, that would be 2 times x minus 4, and then take this entire function and dump it in here. You're dumping the f function into the open position in the g function. So this would be 4x squared plus 2x plus 6. Multiplying everything by 2 would give you 8x squared, 4x, and 12. 8x squared plus 4x plus 12. Drop down that negative 4 and continue combining. So it's 8x squared plus 4x plus 8. And that is g composed of f. Okay, in number 34, you're doing the same thing. You're doing a composition, which is really just substitution of one function into another. In number 34, they give you f of x is equal to 4x squared plus 5x plus 8. G of x is equal to 5x minus 4 this time. And again, you've been asked to do the same type of composition, g composed of f. So try to memorize to get this done. You're always going to open up the front function and substitute the back one into the front. So this would be opening up the g function. In other words, opening up a blank spot where the x is, 5 times x minus 4. Make this a little bit longer so I can plug in the function. And then you're going to dump right in here where the x is in the g function that you opened up. You're going to plug in the entire f function, this expression. So 4x squared plus 5x plus 8. Distributing this 5 to each of these terms would give you 20x squared plus 25x plus 40 minus 4. So 20x squared plus 25x plus 36. And that would be g composed of x. Okay, moving on to 35. On problem 35, you're writing the standard form of the equation of the circle with the given center and radius. So you have the point 5,9, radius of 4. This is the equation of a circle. It's x minus h squared plus y minus k squared is equal to r squared. This is the h and the k, the point at the center. This is the r. So it's x minus 5 squared plus y minus 9 squared is equal to r squared. If there were any double negatives in here, you could clean that up. About all you can do to this one is square out the radius. You are not expected to FOIL out this y minus 9 nor the x minus 5. So this would be the equation of the circle. Center at 5,9, radius of 4. Okay, moving on to 36. In 36, you're asked to complete the square. 36 and 37 are more work because they are not in circle notation, and you're going to have to complete the square in order to reveal the center and the radius. So what you can do here is they give you x squared plus 14x. You want anything that belongs to the x family together. Leave a spot to complete that family. You're going to try and turn this into a trinomial, a perfect square trinomial. Then the y terms are, let's write it in this order, the squared term first, then the linear term belonging to that same family. Leave room to complete the y family. You're going to make a trinomial out of this as well. Then the other numbers that were on this side were positive 49 and another positive 49. So there was this number, there was another one of these on the left. Then there was an equal sign. Actually, let's see, completing the square here, they've actually kind of done some of the steps for you that you had to do in my math lab. So let's rearrange this again. You actually don't have to come up with these numbers. Your homework problems, you did have to come up with them. So in your homework problems, what you would do is you would cut this in half and then square it in order to produce this number that would make this a perfect square trinomial. They've actually already given that to you with these extra numbers. So why don't we put these numbers with the families that they were with. I've given you some problems on this practice test that are partially done. Let's regroup here. So let's leave the 49 with the x squared and the 14x the way it was. Let's leave this 49 with the y family. And then the only thing that was on the right side that I'm going to leave like that is the 9. So this is already a perfect square trinomial because there's a number here that if you cut this in half, you'd get a 7, and then you square it, you would get a 49. That's already the number that completes the perfect square trinomial. Same thing here. This last number is always positive. Even if you cut this in half, it would be -7, but by the time you squared it, it would be 49. So this is a perfect square trinomial, and this is a perfect square trinomial. There has to be a very specific number in that third spot for it to be a PST. Now, perfect square trinomials factor like this. There'll be two terms in here with a square, and all you do to get them, they're super easy to factor. Just take the square root of the front term, square root of the back term, join these two terms by the sign in the middle. So this is all factored. It's starting to look like the sort of equation that we gave for number 35, but it has to be in this form in order for you to tell what the center and the radius is, unless you already knew it, which we did in that problem. But here we didn't know it, but we're going to know it in a minute. This is another perfect square trinomial. You're going to factor that as well to help you reveal the center of the circle. These perfect square trinomials, all you have to do is take the square root of the front term, square root of the back term, join these two terms by the sign in front of the linear term, and then this is r squared. The numbers that you're seeing here, the opposite of these are the center. So your center, also known as h and k, is -7 for the h value, which really plays the role of the x when you're talking about the center if we were going to graph it, and +7. You have to switch those before yanking them out of those parentheses to talk about what the center is. And then this is r squared, so r has to be 3. And that's what you're asked for in that question. 37, let's see if that's already done for you. This is what you're given in that problem. X squared plus 8x plus 16. Then you're given another trinomial, y squared minus 16y plus 64, and on the right side a 64. So if this is a perfect square trinomial, half of this would be 4. 4 squared is 16, so this is a perfect square trinomial. These are the things that you would have to check to see if they've already given you that perfect third number. Cutting this in half, which is 4, and then squaring it, 4 squared would be 16. Okay, since it's a perfect square trinomial, it factors like this. Take the square root of this front term, and likewise on the 16, take the square root. That's all you have to do to get these things factored when they're perfect square trinomials. Many different factoring methods. These just happen to factor very easily. And then yank that sign down on the linear term, therefore this is all factored. Do the same thing on this y family. It is also a perfect square trinomial because half of this is negative 8. Negative 8 squared is 64, so it's a perfect number. Factor this now, square root, bring the sign down in the middle, put a square on it. Okay, now you can tell what the center is and the radius. But since the formula for the circle goes x minus h, you have to think about if you were plugging into this formula, x minus h, and then squaring it, what could you possibly have plugged in here that would end up looking like this? Because that's what the h value is. You would have to have plugged in a negative 4 right here for it to end up looking like that, because the formula is x minus. So your h value is negative 4. Likewise, the rest of this formula would go y minus something would be the k value right here. You'd have to plug in a positive 8 for it to end up looking like that. So positive 8, this is r squared, therefore r is equal to 8. So this is the center. Okay, so x minus h, this would have been y minus k. You would have had to plug in an 8 there for it to look like that. This is the center, this is the radius. And I think that completes all the problems on the review. Good luck studying for the test. See you in class.